In the first video of this video series, I briefly introduced to you guys the difference between a definite integral and an indefinite integral. An indefinite integral was when we had this integrating constant, the plus c, after we integrate. A definite integral is actually, we won't have this plus c, and rather we'll just end up with a singular value. The difference is due to this limits. So we have an upper limit here and a lower limit here for a definite integral. And what we're going to do now is right after we integrate, we're going to actually input these limits and end up with a number. So let's take a look at an example. So let's say we have to integrate x dx, and now we have limits. So this here 2 is known as the lower limit, and this here 3 is the upper limit. So it's 2 to 3. So first things first, we just integrate as normal. So integrating x will give us x squared over 2. But now, because we have limits, we don't add the integrating constant, and instead we have to add or draw some square brackets around what we integrated. So it will be x squared over 2, and then we have this square brackets. And either side, on the top and bottom, we add the limits. So it's going to be 3 on the top and 2 on the bottom. So this is what we'd have to write up after we integrate it. The next step is now we're going to input our limits. So we're going to input the upper limit in first, always. Okay, so in this case, I'm now going to draw it in some normal brackets. So it's going to be 3 squared over 2, close bracket. And now we always subtract the lower limit, so subtracting brackets 2 squared over 2, and we just solve it. So it's going to be 9 over 2 minus 2 is equal to 5 over 2. This is a typical way of writing or solving an integral with some limits, and as you can see, rather than a function, we end up with a single value 5 over 2. This value actually represents a very important characteristic which we can look at later on, but for now we just have to be used to or get used to solving definite integrals. Let's take a look at this example here. So once again, it's a definite integral due to the fact we have some limits, 1 to 9 now. So first things first, let's go ahead and integrate it first. So we'll get x squared minus 2x to the power 3 over 2. This we write inside some square brackets with limits 1 to 9. Now we input a limit, putting the upper limit first, so x is 9, putting that in. Make sure you put it in brackets just so that you don't make any mistakes. So we're going to have 9 squared minus 2 times 9 to the power 3 over 2. Subtracting, like putting in the lower limit of x is 1, so 1 squared minus 2 times 1 to the power of 3 over 2, and then we're going to get 27 minus 1, which is just 28. Using this method, we can also find limits if we're given the definite integral value. So an example would be this question here. So you can see here, if we were to integrate 1 over root x from limits of 1 to k, they say it's going to be equal to 3. So it's just basically, it's like reversing or just manipulating it. So let's integrate it first. So integrating 1 over root x will give me 2x to the power of a half with limits of 1 to k, and that's equal to 3. This we write in square brackets now, right? Now we're going to input our limits of upper limit k first, so it's going to be 2 root k minus lower limit of 1, 2 is equal to 3. Now it's just a matter of manipulating it. So we get 2 root k is 5, k is 5 over 2, k is 25 over 4. That's our upper limit. We can also find terms within a function. So for example, this question here, you can see here we have limits of 1 to 4, and we have the function 6 root x minus a, which we have to integrate. And if we do, they say we end up with a squared. So it's once again, it's just manipulation, but the same process. So initially, we should always first integrate. So we're going to get 4x to the power of 3 over 2 minus ax, because a is just a constant value, right? And that's going to be in square brackets with limits of 1 to 4. And that's equal to a squared. Let's go ahead and input our limits. So putting the 4 in first, we'll get 4 times 4 to the power of 3 over 2 minus 4a minus lower limit of 1, 4 times 1 to the power of 3 over 2 minus a is equal to a squared. Now, if you simplify it and bring it all to one side, you actually end up with a quadratic function, a squared plus 3a minus 28 is 0, which we can factorize to a plus 7, a minus 4 is 0, a is 4 or negative 7. So it's still the same process, it's just the fact that we're just manipulating a bit. But the main thing I want you guys to get or the hang of is definite integrals, just the process of writing out or solving a definite integral question.